So this workshop is on secure medical data collection, best practices with Excel, and leveling up to REDCap and Collaborator. And sorry, that should be a capital R in Collaborator. That's a particular package in R. And I'm going to walk through our structure today. I'm going to talk about best practices in Excel. If you're using Excel or your collaborators are using Excel, how to help them produce the best and cleanest data possible. But we're also going to make the case for leveling up to REDCap and packages as part of the REDCap environment, REDCapR and Collaborator with Will Beasley and Kenneth McLean. So I'll get started with best practices for the clinical research data entry in Excel and spreadsheets. And we're going to focus largely on Excel and Excel's quirks because it is the most common spreadsheet in use today. So for this workshop, we're going to assume that you have access to Microsoft Excel or to a free tool that will let you work with Excel files like LibreOffice or OpenOffice, that you've downloaded the Excel files from this workshop from either Google Drive or your email, and that you can use Zoom to put questions in the chat window. And definitely post reactions. Let us know if, particularly during the exercises, things are going okay. Everybody make sure at this point that you have a copy of Excel or the equivalent, and you have the 3 spreadsheets for exercises. And let us know in the chat if you're having trouble, if you don't have those. This is the link here for the Google Drive. I guess I have to go back. Let me escape out and I will paste that into the chat just in case. Oh, thanks, Joy. And I'll go back to slideshow from the current slide. So hopefully everybody can get those. We won't hit the first exercise until about slide 60. So you've got some time to get those downloaded. So our goals for our first hour is to learn about the pitfalls of Excel, learn how to structure tidy data, and that's a particular kind of data structure. Learn how to store your metadata, descriptions or notes about the data along with, but separate from your data. Learn about some common data errors and how to avoid them, and learn about free alternatives to data management with Excel, which are superior on many fronts, and we're going to focus on REDCap, but which requires substantial investment of time into your research career, which we really think in the long term are absolutely worth it. So one of the big pitfalls of Excel is that it's super easy. You can just open it up and start typing in your data. But it doesn't necessarily produce good outcomes. As in this Far Side cartoon, you can't just throw things together. You can't just throw things in a data set and expect it to be analyzable. You have to be organized and have a plan before you even open up Excel. So Excel is everywhere, but it was designed to help small businesses to help with data entry, act as a sort of database, perform calculations, format tables, visualize your data all in one, sort of a Swiss Army knife for small businesses. But Excel is not great at any of these, so Excel might not be the right tool for your job. And we're going to talk about ways to make it better, but in the long run, why you might want to choose better tools. Using Excel in some ways is like falling into a pit of not great that is hard to escape. And we're going to make the case today that your research deserves better. So what tools do you actually need for reproducible and secure medical research data management? So ideally, you'd start with a data entry tool with data validation. So it would check the data type, whether it's integer or text or date, and the date range to make sure it's reasonable. Tools that make it hard to overwrite data by mistake, data that are secure and private, especially protected health information, good for collaboration. So there's an audit trail of who changed what cell at what time, and hopefully notes on why they did that. It should be good for collaboration. So, and data are easy to analyze, which has a lot to do with data structure. The data analysis itself is reproducible, and any errors are obvious and easy to detect. The reality of Excel is that it's really designed for small data and small businesses, and it doesn't scale well. It is not designed for big data, and it tends to fail. Excel is filled with compromises. It's very easy to overwrite your data. You can type anything into this, any cell, whether even if it's the wrong data type or clear and obvious typos. It's very easy to overwrite formulas or edit them by mistake. And the formulas themselves are hidden, which is great for printing, but really bad for checking your formulas. The reality of Excel is that point and click, copy and paste data manipulation, especially with multiple steps, leads to undetected errors. Our structure and our habits and wide computer screens encourages very wide data, left to right. But Excel is actually designed for very tall data. It has 16,000 columns and a million plus rows maximum. So that really the goal is to have tall data, but we don't often do it that way. And there are many tools on the web that can open password protected Excel files. So your PHI is not terribly secure, even if you have a password. And Excel, and this is possibly the most dangerous, tends to fail silently. So a few Excel spreadsheet horror stories for you. In 2020, the UK COVID tracing program lost thousands of COVID cases when Excel ran out of rows. They had data in CSV format that were imported into XLS templates, which are limited to 65,000 rows. Any extra data rows were silently discarded. And this was one of the dangers of Excel. Someone eventually noticed that they were receiving exactly 65,536 rows every day, 8 days in a row. And over those 8 days, over 15,000 cases of COVID-19 were not traced. Contacts were not tested or notified. And in response to this, Excel was always meant for people mucking around with a bunch of data for their small company to see what it looked like. When you need to do something more serious, you'll build something that works at scale. But you wouldn't use XLS. Nobody would start with that, from Professor John Cowcroft. I think this is generally thought to be true, but a lot of folks who don't know any better are using Excel for applications that it doesn't scale to. 88% of forensically examined business spreadsheets contain errors. More than 20% of gene data sets submitted with scientific manuscripts contain errors. An infamous Duke microarray study of precision cancer therapy due to multiple Excel errors labeled less effective cancer therapies as more effective, leading to bad outcomes in gene expression-driven clinical cancer trials. And this has been in the news a lot, and I'll drop these links into the chat a little later for you to explore. Silent miscalculation in a spreadsheet in 2012 led to a loss of over $6 million by JP Morgan, known as the London whale trade. This was an error caused by manual point-and-click manipulation of spreadsheets. Point-and-click manipulation of data, especially with multiple steps, is prone to errors and is not a good practice for reproducibility. There are a lot of spreadsheet pain points. Data entry itself, spreadsheets are bad for this. There are lots of errors. The typical error rate in studies of spreadsheet data entry is somewhere between 1 and 6.5% of cells. And you can imagine in a large spreadsheet, that adds up to a lot of errors. The FBI National Crime Information Center, which is a database that collects data from multiple sites and tries to merge them, 15% were in error, identified the wrong person, often due to a typo of a middle initial or a name. Spreadsheets often auto-format data to be helpful with unintended consequences. They interpret a lot of things, gene names like March 1 as dates. 27 gene names, in fact, had to be changed in 2020 by an international consensus conference because Excel will not change this behavior. And so 27 human gene names were changed to accommodate Excel. Data entry and dates are particularly bad at this. Dates are stored as whole numbers. Days, and they're stored as days since January 1, 1900 on all Windows and Mac since 2011. But this is different in Mac Excel before 2011 based on 1904 dating. And ugly surprises can occur because if you move dates between one spreadsheet and another or into or out of Excel, it will do this formatting automatically, silently. Another big problem with data entry is what's called an off by one error. And if you think, oh, you know, it's only 3 to 4% errors, it's not so bad. This is a problem that's not so specific to Excel, but you often get what's called an off by one error. So if you're missing a return, like in column 1, someone's typing along blood pressures, systolic blood pressures. They type in 127, they don't quite hit the enter key. Then they type 136, they hit enter, and they keep going. And they get to the end and they've run out of numbers, so they leave this blank. When you ship this to your analyst, you hope that they see this and say, oh, this is 127. I wonder what this 136 is, and then figure out that, oh, that's patient 5 blood pressure. this belongs to patient 6, 7, 8, 9, and move them down. It's very easy, if you're not thoughtful about it, to go to the source document, change this to 127, throw out the 136 and say, oh, I guess patient 9 never had a systolic blood pressure. Or similarly, if you hit an extra return here and you have a missing row, a cell of data, when your data entry person, who sometimes is wildly underpaid, gets to the end and says, that's weird, I have an extra number. You would hope they would let you know and figure out that, hey, this one belongs to patient 4, this one to patient 5. But if they don't, if they just go shrug their shoulders and move on, instead of having one error, you've got a whole column of errors after that problem. So it's really important to think about off by one errors and figure out ways to make data entry more foolproof. So better data entry for medical research data, you want data entry forms with clear labels corresponding to the patient and the field rather than open sheets to reduce off by one errors. It's best to use a tool that's secure and protects PHI. And it's best to use a tool that can validate data at entry. Excel isn't necessarily very good at that. It will accept a date like this or a blood pressure of 1047. If you enter a potassium of 6.7 dash but lysed, it will turn the whole column into characters rather than numeric. And if you put in, if your N key sticks during Hispanic, it will assume this is a completely new category that's distinct from the original Hispanic with one N. It's also an issue with security and privacy. Spreadsheets and Excel were really not designed for privacy. Excel, when it was designed, assumed that all data were on floppy disks pulled out of a computer at the end of the day and locked in a drawer in a locked office. All the data were on a removable disk that could be locked in a safe, and this was before hard drives were a thing. You can password protect spreadsheets, but lots of programs on the internet can open locked spreadsheets without a password. Then there's formula security. Formulas are hidden in cells. They're not visible. They're good for printing, but bad for checking the formulas. You can easily have errors missed. You can easily overwrite them just by typing. You can type data over a formula. Nothing will stop you. There are no warnings and no audit trail. There's no way to track who changed this formula or why. And an audit trail means you should be able to take your raw data, repeat every step, track every change, who made it, when, why, and end up with the same final result. If you can't do that, you don't have reproducible data analysis. As an example, in 2021, I contacted 4 well-known authors of papers published in the last 5 years in my field, so not that old, to extract data for a meta-analysis. None of the 4 had access to the raw data. So there was no reproducibility of papers that were published less than 5 years ago. Another big issue is that Excel fails silently. So a problem like too many rows or changing formulas by typing over them doesn't trigger a warning, an error, or anything. It just lets the user do it. And when something goes wrong, there's really no way to tell. And this is why forensic accounting has become a field, going through checking every cell and checking every formula to find out what really happened. And Excel sort of encourages wide data, not officially, but technically Excel wants tall data. It always expects a lot more rows and limits. There's a lot more rows available than columns, suggesting you really should have tall data. But most users record data over time from left to right. And that some of that is just our habit, reading from left to right. We also like to avoid scrolling, and our usual screens are wide, not tall. And this creates unwieldy data files with many identical column names. If you do multiple visits, screening, randomization, treatment 1, treatment 2, and record the date and systolic blood pressure at each one, you end up having to create this other header row, extra header row for the visit, which really should be a variable. And you have the column name date repeated 4 times, which is very confusing from the computer point of view and difficult to analyze when you have 4 distinct SBP measurements in the same spreadsheet. So why do good research people do bad data things? Some of it is habit. The screen is wide. We want data to fit on the screen. We don't like to scroll. So we tend to make wide data. We read from left to right. When we add new data, we tend to add it to the right side as it's new data. We also don't like to type that much. We want to avoid repetition, which leads to variables stuffed into the headers. Excel actively encourages us to encode data as colors. There's actually a button for cell styles. And Excel is silently helpful on data types, changing genetic data to dates, or changing numeric data to text if even one character is present. And since Excel enforces no rules, we can do anything, even if it's a bad thing. So the temptations and limitations of spreadsheets, it's easy. Excel is very accessible. It's being used for purposes for which it was never designed. Excel frequently fails and fails silently. Manual point and click, copy and paste leads to errors. Separating data entry, calculations, and reports is a very good thing. And it's important to use tools fit for purpose. And there are certainly better tools than Excel. So our recommended data tool for medical data is REDCap. It does all the things. There's data validation, PHI is protected. There are data entry forms, standard data entry forms for things like demographics. It's available for free at almost 5,000 institutions worldwide. It may be over 5,000 now, in 141 countries with over 1 million projects and 1.6 million users. And this is where you want to end up, even if you're starting at the point of data entry with Excel. Now you may say, I really need to do this now, your data collection, your data analysis, and you don't have time to invest in REDCap or learning this. And in this hour, we'll focus on how to best use spreadsheets to minimize data problems. But in the long term, if you're committed to medical research, it's worth investing the time to learn REDCap and worth investing the time to learn some R and or work with a statistician who uses R, open source software to analyze your data so you can see the code and understand what's going on. So onward to tidy data and best practices for spreadsheets. So tidy data is a data standard. I'm going to talk a little bit about this over the next few slides. So why do we need data standards? Data sets can be in all shapes and sizes, but data manipulation tools need data standards. If you can build your data set in a standard format, there will be a lot of tools to work with your data. And tidy data has become the standard data format since 2014. And many statistical tools work best with tidy data. So tidy data is a standard way of mapping the meaning of a data set to its structure. In tidy data, each variable forms a column, each observation forms a row, and each cell is a single measurement. You don't combine two measurements in any given cell. The standard structure of tidy data means that tidy data sets are all alike and can be used by the same tools, but every messy data set is messy in its own way. Working with tidy data means you can use the same tools in similar ways for different data sets. But working with untidy data often means reinventing the wheel with one-time approaches that's hard to iterate or that are hard to reuse. So having a data standard promotes collaboration. It's easy for other people to work together because you share a consistent data structure and you can pass the data from one person to another to do different steps. Having a tidy data standard makes building data pipelines easier with standard inputs and outputs to each function. So let's walk through this a little bit. We can work with this in chat. So we just talked about what makes data sets tidy and untidy. Why is this tiny data set untidy? And my hint is we should only have one unit of information per cell. So in the chat, can anybody take a stab at why this data set is untidy? And feel free to jump in. So looking at this one, yes, 2 pieces of data in one cell, it's the blood pressure screening problem. So we've stuffed systolic and diastolic in the same cell, which is a very common parlance in medical data, but makes it a lot harder to untangle those. So ideally, the tidy version of the same data would separate SBP and DBP and identify the visit at the screening visit. So separating out the screening piece of blood pressure into its own variable for visit. So if you had a visit 2, visit 3, that could be discriminated as well. One measurement per cell. It's also notable tidy data is often more cells, a little bit more typing, which is why sometimes we're reluctant to do it. So here's another example of untidy data. So why is this data set untidy? And the hint here is you're going for one observation per row. So exactly, there are two different visits, two distinct observations going on, the pre-visit and the post-visit. So a tidy version of the same data has a time or a visit column, that's the pre and the post. It's notable that now we have one measurement per row. Tidy data is often taller, and tidy data is often more cells, in this case, 18 versus 9. Here's a third example. So why is this data set untidy? And the hint here is each variable or same measurement should form a column. So to some extent, we've stuffed a variable into the header row. That makes sense. There we go. So we want to separate the visits into its own variable rather than stuffing it into the header. So we have one column for visit, one column for SBP. Again, tidy data is often taller and more cells, but it makes it a lot easier to analyze. It's in the standard tidy data format. So unfortunately, when you bring untidy data to your local statistician, you will often get the glare of death because they have to spend a lot of time wrangling the data. That could have been prevented if you can set up your data set as a tidy structure when you collect your data. So talking about good data practices. So using spreadsheets and trying to build tidy, clear, reproducible data that makes analysis easier and prevents problems later. I'm going to go through 14 good data practices. So first is making clean rectangles of data with no more and no less. So tidy data structures that are very clean, very vanilla. So your data sheet should have one row, the header row of variable names, no extra header rows, no titles, no notes, lots of data, no blank lines or columns, and no empty cells, and absolutely nothing else. So here's an example that is not a clean rectangle. There's an extra title. There are global notes on the data down here, and there's a note on an individual data point. These are all metadata that should be stored on a separate worksheet. So a common problem is extra headers. So here's our header row, we would think, single header row, but we have an extra header row for visits. And we talked about this in the last few slides. It's actually encoding a separate variable, the visit number. So you need a column for that in your header row for visit number. You don't want to have the same measurements appear twice in columns. And if you're seeing that, that suggests you're putting more than one observation in a row. It's also very confusing for the software, the statistical analysis software, to have SBP twice. Which one is which? DBP twice. It's best to have unique variables throughout your data set, one for each column. And avoid empty cells. And why not have empty cells? Well, a truly empty cell looks the same as a cell with a space or a cell with 3 spaces that somebody just happened to hit the space bar a few times. But to a computer, they're completely different. And it's better to fill empty cells with a clear marker that it's not available or empty. And NA is the standard, capital N, capital A. In the past, people used code numbers like -99, which seemed like a reasonable idea at the time, but it can cause real havoc if someone tries to do math later using that number. You can get crazy numbers and not understand where it came from. If you want to store details on why the value is missing, store it in your notes or your metadata, not in the data frame itself. You want to end up with clean data rectangles with one header row of variable names, none of which are repeated. Every row is one observation. Every column is one variable with none repeated. Every cell with one unit of data with no blank lines or columns. Any empty cells should be filled with NA, and no stray notes or titles that you've stored elsewhere. Number 2, use consistent variable names. Consistency makes computing a lot easier. Using a consistent case for variable names is really helpful. To humans, capital BP and lowercase bp are both blood pressure, but to a computer, these are completely different. So in general, avoid capitalization. Computers struggle with most punctuation. A lot of times the punctuation is used for various functions. So avoid punctuation other than underscores or dashes. And humans have no trouble understanding something like BP standing, but computers struggle with spaces. They wonder, are BP and standing two different variables? So it's helpful to avoid spaces and replace these with underscores or dashes. And generally, lowercase, or what's called snake case with an underscore between lowercase words is recommended. So lower snake has things like SBP, millimeters of mercury, heart rate in BPM, AST in international units, albumin in grams per deciliter. And note the units are attached. That can be really helpful if you're looking at your data years from now and you're not 100% sure because the standard units have changed 5 years later. Include the units and variable names if there's any possible way someone could guess wrong on units. Imagine someone new opening the data set in 10 years. Typically, we'll use the variable name, underscore, and then the units. And consider these as two distinct chunks. So you get an underscore between chunks and words within chunks if you have more than one as a dash. So millimeters of mercury, grams per deciliter, millimoles per liter. Don't encode data with color, even though Excel encourages that. Avoid using font color or highlighting. Your data should be plain vanilla. Highlighting or font colors are easy for humans to read. Computers are colorblind. Computers need ones and zeros. This was an example of encoding the study arm as two different shades of green. Not a great idea. Humans can see it, but the computer has no idea. So you want that variable encoded as a distinct variable, as a distinct column. It's clearly labeled as intervention or control or 1 or 0, however you want to encode it. In general, it's a good idea to make it human readable as well as computer readable. So a short text name that's clear is really helpful. Some folks like to use sort of 1 underscore intervention or 0 underscore control. So you have both a number and a label kind of stuck together. I think that's generally a good idea, but whatever your preference is, as long as it's clear. Be consistent with categorical variables. Always use the same spelling and capitalization. Unfortunately, humans aren't nearly as consistent as computers. So humans know that Hispanic, lowercase Hispanic, Hispanic with 2 N's, or capital H are likely all the same value in a categorical ethnicity variable, but computers don't know that. They think these are 4 distinct things. And it's really hard to be consistent, to avoid typos, spaces, changes in capitalization. Even inadvertent spaces at the end of the word, which are invisible to humans, look like a different category to computers. So you need to structure your data entry for success. Use consistent capitalization and set up dropdowns in Excel for each categorical variable. So this can be done, and this is a great opportunity for our first exercise. So go ahead and fire up Excel and open the exercise1.xlsx file. And I'm going to try to do the same on my second screen. And sorry, my computer decided to verify my copy of Microsoft Excel at the moment. Okay. I'm going to switch to Excel. There we go. And you should see study site there. What we're going to do is get back to on this data sheet. We're going to create a column for a categorical variable, study site, and we're going to add a new worksheet with the plus sign here. And we're going to double click on that and call it catvar for categorical variable lists. So now we have this sheet, which will store the allowed names for our categorical variable. And we're going to start with study site, and this should be identical to our study site on the first sheet, the data sheet. And in the column between the study site, we're going to add 4 values. We're going to start with Ann Arbor, then Boston, Chicago, and Detroit. So we have 4 values to work with. They're in A2 to A5. And these are going to be the allowed values for this variable. And we're going to set this up so we don't have to worry about capitalization. We don't have to worry about typos. It will protect us to some extent from those common human errors. So now that you've got this set up, go back to your data sheet and select this study site column. We'll go down, say, 26 rows or so. And then click on the Data tab in Excel. This is up here, Data. Now, if anybody's having trouble, say so in the chat. If you got behind, if you're struggling, let us know. But if you're caught up, this is great. So you clicked on Data. Then you're going to, you may need to widen this up to be able to see this. Click on Data Validation. And that's here in the Data panel. And I'm going to click on the drop down and click on Data Validation. And it's going to ask, okay, what are your validation criteria for this column? And I'm going to say list. I'm going to allow a specific data values that are in a list. Then I can click the source. So now I'm going to give it the source of the list I want. And then I'm going to click, go back to the sheet, catvar lists. I'm going to move this out of the way. I'm going to select my values, not the study site, just the 4 values. And it should look like equals the sheet name, catvar lists, an exclamation point, and the 4 values from $A, $2 to $A, $5. If you've got that right, then you hit OK. And Jason asks, can you back through that and do that again? So I'm in data. I select the column I want. Then I hit data and then data validation, which is this icon here. And then I hit the drop down and hit data validation. That pops up this window. And then I want to allow a list. I click in here and then I actually click out of the box in catvar list to select the values I want. Once I have the values I want, I can hit return or hit OK. And that takes me back to study site. Okay, looks like Jason's caught up. Everybody else looks okay. So now you notice there's this little drop down arrow next to study site when it's selected. So if we select the first study site and we click, we can see there are only 4 options. We'll put Ann Arbor, we can put Chicago, we can put Detroit, we can put, I'm going to get this right, Boston. If I type a capital B, it'll bring up Boston, a capital C will bring up Chicago, and it's working well. What's interesting here is if I try to type in an E name like El Paso, value doesn't match the data validation restriction defined for this cell. I got to start over, hit retry. I type in D, I get Detroit, I hit enter. So you can limit, and Ray asked, why limit to the first 26 rows, not the column? I could absolutely do the whole column. So I can do the same thing just to walk through it again. Data validation. I want to extend it to these cells. Yes. And this is what I want. Sure. And I can have, an infinite number of rows in this column. So Ray, you're absolutely right. I could do that. And, even if I click on an unentered, it has this drop down. I can select one of those 4 values. Okay. Please put questions in the chat. These are great questions. But I think that gets us to where we want to go. Okay. So I'm going to see if I can stop sharing this one and go back to sharing my PowerPoint again. And so we went back, we entered, press return, enter, slideshow. And if you type in an unallowed value, it won't let you. Okay, so I think we got that down. Caitlin asked if you don't click the whole column, it won't apply by default. That's correct. If you want that whole column forever, click the whole column. And yes, it does assume the first row is a column name. And I think we're good on the questions. Feel free to ask more if it's not clear. Yeah, you just select the values. I think I get what Caitlin's asking. So in the CatVar lists spreadsheet, I just selected the values, not the header name. I just put that there for my reference so I would know. So eventually you may end up, if you have a big data entry project and multiple categorical variables, you may have your CatVars lists sheet may have 10 or 15 variables on it. So it's helpful to have the header there so you know which variable those options go to. So all of your categorical variables or factor variables, you have the list of all the allowed options. Okay. Everybody in good shape on that? Feel free to put more questions in the chat if not. Okay. I'm going to go ahead with dates. So be consistent with dates. Unfortunately, dates are a messy, poorly standardized data field. There's so many ways to mess up dates. You can do month, data, year. You can do 4-digit year, you can have dashes, you can have slashes, and many more. It's common in the US to start with the month, common in Europe to start with the day. You can use numeric months or text months. You can use 2 or 4-digit year, dashes, slashes, underscores as separators. And this creates many, many problems with international collaboration. So fortunately, there is actually an international standard, ISO 8601, established in 1988. By the International Standards Organization, no surprise. And the data standard is 4-digit year, 2-digit month, 2-digit day. That is the standard. Computers get this and they can sort dates in this format in chronological order, which is pretty darn helpful. ISO 8601 also includes standards for hour, minute, second, and time zones and lots of other things. And you can look it up at this link. So, and you can format your Excel date columns to ISO 8601. So if you enter a variable name in column B, and let me just see if I can hop back and demonstrate that. I'm going to switch my sharing again. So say in column B, I had date, and you can enter a couple of valid dates. I'm going to do 1/5/19, 3/7/20. And it looks like I may have already formatted that one. So if you have, sorry, I may have already formatted these. So let's do, you can command 1 to go to formatting, select the column, and I'll put standard formatting back on. So 2/14/19. And if you want to format this to ISO 8601, select the whole column with whatever dates you have. I hit Control 1 on Windows or Command 1 on the Mac That takes you to the Format Cells window. The third one down is your ISO 8601. It starts with 4-digit year, 2-digit month, 2-digit day. And click OK, and all subsequent dates will be plugged in. So even if you type in 1/4/18, it'll convert them, which is pretty darn helpful. Keeps you out of trouble. It's not perfect. You can type in dates and leading zeros will be added. So it adds the 0104. So it's standard 8601, but it won't prevent things like the 15th month. So if I enter 2020, 15, 15, 15, it will accept that. Now, it'll accept it silently. It won't say, hey, that's not a valid date. What it will do, it does know it's not a valid date. It will format it as text, and that's why it's left justified. But it's silent unless you know to look for that, and your column's wide enough to see that. But imagine your column's pretty narrow. It's not obvious that that one is left justified, no others are right justified unless your column's wide enough. Now you could note that the font's a little bit different, maybe a little bit bigger, but it's pretty subtle unless your column's wide enough. You could see somebody just typing along and, doing 2020, 2021, 2748, and it doesn't really complain. That's part of the sort of silent failure of Excel, unfortunately. I'm going to swap back to my PowerPoints. Another thing is to be consistent with subject IDs. They should be clearly assigned to each participant. Each study participant should have a unique ID, usually numeric. Particular to your study, it must be unique, cannot be their name. This should not use or even be derived from a medical record number, birth date, name, or any other item of protected health information. Ideally, you would assign a unique number at the first contact and keep it through screening and enrollment. You may choose to use a unique prefix for each study site to allow ID assignment across sites. 15-00041 would be the 41st participant at site 15. Or you can keep site and participant number as separate variables if that's easier. You should also be really consistent with files and file names. And make sure you use a consistent file structure. Be sure that if multiple files are used, like if you have a different file, data entry file at each site, they have exactly the same data structure, exactly the same variable names in the same order, with the same categorical dropdowns and data validation rule. Ideally, set up one data template, test it in a pilot at multiple sites, and then finalize it and make sure every site is using the same template that is locked and can't be edited. This is a lot easier to do with a single unified REDCap database across sites, but if you're stuck using Excel, this is what you want to do. And you want to check and validate data from each site and file frequently, especially early on, and make sure no one's inadvertently editing the data entry Excel file. It's important to use consistent file names if you have multiple files with different data types, different sites. Decide what the key naming chunks you need are in what order to identify the data, and use the same name chunks in the same order with underscore separators. So if your pattern is study site, data type, and CSV, then blood pressure study, data from Boston, and the labs data. Blood pressure study, data from Chicago, the vitals data. So you have a sense from looking at the chunks of what's in it, where it's from, and which study. And generally, you're going to separate the chunks with underscores, separate words in a contiguous chunk like BP study with dashes, just a standard format. Be careful with text strings, especially gene names. Excel tries to be helpful and guess the data type in each column. Any column that looks a bit like a date gets turned into a date. Any column with text into it gets turned into a text column. And that's why you should never add text notes to the data, especially in numeric columns. You can and should set the format of a column in Excel. Same idea, select the column, Command 1, format cells as text, turns off the helpfulness for that column, just pushes everything to text. You can sort out the details later. It's important to include a codebook, which is a detailed description of every variable in your data set on a different sheet in your Excel workbook labeled Codebook. And we'll show you an example in something called Organize, one of your downloads. But that has columns for variable definition, how it was collected, the data type, the units if it's applicable, or the allowed values, categorical, or the range for numeric. You should do no calculations in your data sheet, just the data, just the facts. One sheet in your Excel workbook should be labeled data and should have only raw, tidy data in a rectangle with no calculations and no formulas. Formulas can be altered, typed over, or deleted silently. Let your statistician or statistics program do the calculations in a reproducible way. It's helpful to record raw granular data within reason. You want to record the raw data in the most granular form that's reasonable. Rather than recording age, which is a calculation and a fairly rough estimate, record the date of the visit and the birth date. You can calculate the age very exactly later. Record the date of diagnosis rather than years of disease. Again, you can calculate that later. You don't want any implicit calculations. Get the source data, get it as granular as is reasonable. It's important to use data validation to protect yourself from data entry errors. We talked about categorical data validation earlier with the lists. Data validation is a set of rules for each variable or column that restrict the data type and the range of allowed values. Setting up data validation for each variable dramatically reduces errors. The data entry error rate is 3 to 5% per cell without data validation, less than 1% with DV. Data validation is not the default for Excel, but it is available. Only double data entry with data validation from source documents is better. And double data entry means you're paying two distinct people to enter the data from your source documents and then cross-checking them against each other. That is definitely better, but more expensive and more time. So how do you set up data validation in Excel? For each column, decide on the data type, format for numeric, character, categorical, or date, and set up restrictions, whether it's numeric, decide on the allowed reasonable minimum and maximum values. Categorical, make a list of the allowed variables. For categorical lists, we talked about setting up a sheet in your Excel workbook named CatBar lists, just for your list of allowed values, one column per categorical variable. And as Caitlin pointed out, you just want the allowed values, not the variable name, because then that will become an option. So let's do this quickly for a numeric variable with exercise 2.xlsx. So let's open that up, and I'm going to jump over to that. I'm going to unshare and then reshare. And get to exercise 2. Sorry. Okay. And for this one, we've got a heart rate column that we haven't filled yet. It's labeled HR. Let's select the entire column and do Command 1 for Mac or Control 1 for Windows. And we're going to format to numeric. And we're going to have no decimals. So reduce the decimal places with a little arrow key. And then okay, so now it's numeric. That's good. You can't enter text or something goofy, but we also want a little bit more control of the data so no one enters, 4,000. So again, we select data, the data validation, and we're going to allow not any value, but we're going to select whole numbers between, and just to be reasonable, let's say maybe 20 and 220. I'll just pick those as reasonable, albeit pretty low and pretty high. We're not going to get a lot of data entry errors. But if you then enter 21, it's fine. 219, it's fine. But if you try to enter 19, it won't let you. You've got to enter 29, or 240 is not allowed. 215 is. And so you can set reasonable limits to prevent the inadvertent sticky key or crazy number that will throw off your data set. You have to set the numbers reasonably wide so you're not constantly getting queries, But I think you have a pretty good sense for most of your variables, what's reasonable. And you can change that if that becomes a problem. If you're studying severe hypertension, you might need a higher limit. So any questions about that, feel free to put those in the chat. So the numeric validation is a little bit more straightforward, but the same pathways. Select the column, data, then data validation, and then what's allowed. Okay, I'm going to head back to the PowerPoint. It's also important to protect your raw data. You should treat this like gold. You spent enormous amounts of time, effort, and probably money to collect this. So always have backups both on-site and off-site. Never modify or overwrite your raw data. Make copies and modify those, and then save it as a new data file. So files should be a progression from study raw data to study clean data, study analyzed data, all the way through. You should always be able to retrace your entire audit trail from the original raw data, all processing steps, to the final products, figures, tables, manuscript, etc., or your research is not reproducible and is not very trustworthy. So putting it all together, taking these recommendations and showing you an organized Excel workbook, and you can open the Excel file titled organize.xlsx and just kind of go through it. I'm going to go through it on the slides, but you can see this example. And it's really helpful to use Excel as a workbook so that you have multiple tabs and typically use at least 5 tabs or more. So it's tempting just to open up an Excel spreadsheet and just start entering data, but it's better to start with a plan. You need worksheets for data. That's your clean vanilla rectangle. Your code book for each variable. Your notes overall, so notes on the overall data collection, what the study is about. Notes on individual values, your data validation lists, and if you want to, you do traditional Excel stuff to make a pretty formatted version for printing or sharing with others. But that should be in a separate tab. So your data tab should be plain vanilla, no colors, bolding, comments, or notes, just a rectangle of data, a single header row of variable names, and no empty cells unless they have NA. Your code book should be very clear for every variable, what the definition is, how it was collected, data typed in units. You should have one sheet that's just about the overall data collection, what the project was, dates, who was involved, who, what, when, where, why, and how, and where the data was collected. Then a worksheet that you can add notes or metadata about individual data collection. One way to do this is a meta note on the actual problematic cell. So if you right-click on a problem value, you can get a drop-down that says new note. You can type in an explanatory note about the data collection, and it leaves a little colored rectangle. If you hover over it, the note appears so you can see the note, but it won't interfere with reading the data into the statistical program. It's not part of the cell. Don't put this information into the actual cells, but you can put it in these notes. Use NAF missing, and this is a workaround that's pretty practical and fairly easy to do. A little bit more complicated way to do this is on sheet 4B. You can have every troublesome data point, describe it, the SPP for subject 7 at visit 7, and then your notes about it. What happened, what's wrong, platelets clump, hemolysis of sample, you name it. And don't put this information on the data sheet. A fancier version, and this is sort of the Cadillac, is basically copy your structure from the data worksheet to a new tab, leave the identifying header row, and then reformat all these columns as text. Leave these blank unless there's a problem, and then fill them in if there's a problem that, oh, the blood pressure was taken standing or prone when it was supposed to be sitting. And this allows you to identify recurring issues with particular variables or recurring problems with particular subjects. Your 5th sheet should be your data validation list. And here are a couple of more examples for categorical variables, NIH ethnicity, NIH race standards. And your optional spreadsheet, this is where you can go wild, format it, color it for showing to other people, not for data purposes. But make an extra tab, do that. Just don't pollute your other tabs with this. So to summarize best practices, you can set up clean and tidy data rectangles where missing equals NA, with one observation per row, one variable per column, one unit of data per cell. Use consistent variable names with no spaces and snake case, including units. Do not encode data with color or in headers. Be consistent with categorical variable values. Use dropdown lists. Be consistent with dates. Use the ISO 8601 standard. Every participant gets a consistent unique participant ID. Be consistent with files and file names, no spaces, limited punctuation. Take control of formatting of categorical variables with dropdowns. Include a codebook. Include notes on the overall study. Include notes on individual values and measurements gone wrong. Do no calculations, including implicit ones, and collect granular data. Use data validation to prevent errors. Protect your raw data. Always keep backups. Never overwrite your original raw data. Document any and all changes in your data to create a reproducible audit trail. And use at least 5 tabs in your Excel workbook with this model. Now, there are even better research practices, making your research data more secure and your analyses more reproducible. With REDCap for validated secure data entry, with R for data analysis, visualization, and reproducible reporting, often using R Markdown. And if you cannot access your data and reproduce your outputs, whether it's tables, figures, or the whole manuscript, 3 to 10 years later, your research is not reproducible and is not trustworthy. And if you're in medical research for the long term, you should invest in yourself. Invest the time into learning REDCap and R. So further resources, this talk was inspired by 2 important free papers, both worth reading. Links are here, and these are in the downloadable PDF, and I'll drop these in the chat as well. And what are next steps? Feel free to ask questions in the chat. Upcoming in this webinar, REDCap for a single site study, REDCap for multi-site collaboration. And if you want to jump into REDCap, there are great resources online, including video lessons. A couple of questions. What's the difference between a note and a comment? So you can attach a note to a specific cell without being linked to the data in any way. So you can still read in the data for a PRET. And Richard actually pretty much answered that. The PowerPoint file is in the Google Drive, but I know Raymond had trouble with that, so I can email that to you. And an existing spreadsheet can be imported to REDCap if it has appropriate header names and is neat and tidy. Okay, so I'm going to jump out. Feel free to ask more questions, but I'm going to turn it over to Amanda for the next step on the introduction to REDCap.
Thanks. So what I'm going to do in this time period is I'm going to give you a quick overview on what REDCap can do, and it will be very quick because Peter did a great rundown of some of what REDCap's capable of and some of the variation between that and R. And then I'm going to take you into a REDCap project itself and let you see kind of how a database gets set up, and then walk you through ways of collecting your data from your participants, and then some of the checks that REDCap has built in, and some of the export abilities that it can give you. So going ahead and getting started. Share my screen and actually switch to the PowerPoint for getting started here. So this is just a quick overview on what REDCap is for people who haven't worked with it before. REDCap stands for Research Electronic Data Capture. It's developed by Vanderbilt University. And what it really is a HIPAA-compliant secure tool for medical research data collection. So it collects data through online data entry, surveys, file imports, mobile data collection, API data imports. And it's a very versatile tool. So it has a very customizable project design. You can use it for e-consents. Depending on your institution, you can also use it for Part 11 compliant e-consent for projects that have that extra standard that they need to reach. Not every institution will have gone through the validation process of making their e-consents Part 11 validated, but REDCap itself is capable of it. You can send out surveys via email or SMS for data collection. It supports multi-site projects, longitudinal projects, piping, branching logic, and default values. And then you can create reports, see basic statistics, and export for CSV, Stata, R, SAS, or SPSS. Starting in version 11, you can also have project dashboards that are kind of Tableau-esque, not nearly as versatile as what you'll do in R with them, but a good way of just a quick display of your data. And to help protect your data, REDCap projects have multiple phases. Development is for creating, editing, building your database forms, testing everything out. This is where you're going to experiment. This is where you're going to be breaking things until you find out what works. And this is before any real data goes into your project. Once you are ready to start collecting data, you move into production. And in production, this will, most institutions will have this locked so that when you make changes, for all REDCap, when you make changes, you're making it in a little pocket that won't affect your regular database. And so you can see what changes you've made and exactly how they're going to affect your database. And at most institutions, if there's any chance of those changes affecting the actual data itself, you've deleted something, you've changed your coding on a multiple choice field, that will go through an administrator who can verify with you that you're aware of all those changes and that you know what impact it's having on your data and you're okay with that, or who can work with you to prevent it from harming your data. So it adds an extra check to keep you from accidentally changing something that inadvertently changes your data. Once data collection is done, there's analysis and cleanup mode. So this is where data collection is stopped. You can choose if you're able to edit the existing data, but this is really intended to be a free state. It can be returned to production, and keyly, you can still export your data. And then when the project's complete, you can it removes it from your list of project databases. Data is inaccessible. So it's fully archived at this point, but an administrator on your system would be able to return it to production. So I'm not going to go through all of this because we just got it, but REDCap is a HIPAA compliant system. The data is encrypted in transmission. If it's encrypted at rest, depends on the institution. We've got role-based security, a complex audit trail. It creates a code book for you as you go. It is a flat database, not a relational one, with very large, we've yet to fully come up with a file size limitation. You can import your data through a CSV file or API, and you can export the data into CSV, SAS, SPSS, Stata R, and you can use APIs to export the data as well. And it is remote accessible. It is entirely a web-based platform, but it also allows, there's also a mobile app to allow for offline data entry. So for people collecting data in areas where they may not have a reliable Wi-Fi connection, and an application called MyCap as well for a more participant-focused way of managing your project. So you've got a project, you know you want to do it in a secure fashion. First step is to figure out, do you have REDCap available to you? Easiest place to go is Project REDCap Partners. You can just enter your organization and it will pull up if you have REDCap and who your administrators are, so you can reach out directly to them. If nothing's coming up there, most REDCaps are run by some kind of CTSI department or by your IT department, so you can always contact them. It is available internationally, so you can see this is an old map. REDCap is in many more places at this point, but pretty much wherever you are, someone probably has. There's probably a server. If you are someplace and you find out you don't have REDCap, that doesn't mean you can't use it. If you reach out to the Vanderbilt team, they have REDCap. They host REDCap projects for a monthly fee, and they can help you work with that. And there is also the REDCap Cloud, also available for a fee depending on the project. So those groups would be happy to work out a hosting mechanism with you for your secure data hosting needs. REDCap training varies by institution. So when you reach out to your local administrator to find out how you use REDCap, they'll let you know about any training requirements for your specific institution. Inside of REDCap, Vanderbilt has provided videos on how to use a bunch of the specific features. There's a very detailed FAQ that's kept pretty up to date. And there's always a contact the administrator link. And then here for a bit of a personal plug, at University of Colorado, we have a series of really detailed training videos as well. We go through all the basic features of creating a project, and then we have, I think, 15 features going in depth on key features like using this for e-consent, using different parts of the surveys in different ways, importing and exporting data. I also recommend the University of Washington training series as a great curriculum that you can check out that's available to anybody. And the Cincinnati REDCap Resource Center, if you're not looking for videos, again, great list of REDCap resources that you can check out if you don't have a formal training or if you want to go beyond what your institution offers. And for questions and follow-up here, this is my email so that people can contact me after the presentation. And that's the PowerPoint, and let's actually get into some REDCap here. Come on, there we go. So this is the heart of a REDCap project where you're going to come in and set things up. And it would take me more time than I have today to sit down and create an entire project with you completely from scratch. But I wanted to give a quick example of, so you can see the different ways that REDCap handles field types. So every field type in REDCap is validated as a specific type, accepting text, designed to do calculations. We recommend really only doing pretty basic calculations in REDCap for the most part. Unless you need it for your project, wait and just do it on the back end with a specialized program. But REDCap can handle up to some fairly complex calculations at this point. Multiple choice questions in dropdown or radio format, your pick one, or your checkbox, pick all that apply. Some hard-coded yes, no, and true, false fields. Those are hard-coded with 1 yes, 0 no. E-signatures, file upload fields for the person filling out the form to upload things. Sliders, descriptive text where you can embed images, videos, audios, or file attachments. Every REDCap field has the field label, which is what you see when you're doing data entry, and the variable name, which is actually how the data is stored. This variable name is the important one. This is how everything is linked. It's a MySQL backend for REDCap, and this is how everything is stored. On text fields, then you can choose your validation type. So you can say only accept dates, date times, emails, numbers. You can specify your decimal points. And this validation is hard, so it will completely reject any data that is not in that format. You can also, on date and number fields, include a range, an expected range, so minimum, maximum dates or numbers. These are soft validations, so it'll give you a warning if you're outside of that range, but it will allow it to allow for an outlier. You can make a field required so that people have to answer it to move on. You can mark a field as an identifier to make it easier to strip from the data. And then you can add field notes, which are small reminder text underneath the fields, and these are great places for specifying units and other information like that. And all of this will automatically be put into the codebook for you as you're creating it. On multiple choice questions, you'll list your choices out one per line, and then each one has this code. So I've got 1, 2, 3 here. That, like the variable name, that's how things are actually stored in the back end. So once you have put in your coded answer choices, you want to always, you never want to change them. You want to keep them the same. And to keep yourself consistent throughout the project, you can copy answer choices as you've used them someplace else. So you can see we have slider fields. I've embedded videos. I can use matrices. I can upload a file or add a signature. I can also use branching logic. In REDCap, branching logic lives in the child question. So this question will only appear if the person selects yes to optional procedures. And I can use piping. So if I want the person's name to as entered in the first and last name fields to show up, I can pipe that information into a later field, into a survey invitation, into an alert, pretty much anywhere in the project. I can pipe that information. This is also set up with the REDCap's eConsent module. So eConsent, this is part of this is a Part 11 compliant framework where you version control, you select your name fields, and I will show you in just a moment how the data entry works. And it will capture a signed PDF and store it in the project along with the regular data store. Now, if I want to move a field and a form in between REDCaps, I can download it as a zip and upload it here. And if I'm using a common validated instrument, I can actually try and import it from the REDCap library as well. So the search function in the library is not perfect, but I can search for it, and anything with this red star next to it means that it's a validated instrument that we have gotten copyright permission to include in here, and it has gone through a series of checks from the REDCap Library Committee to make sure that it has been properly translated between its paper format or however it was developed into REDCap. And I can just click on it and import it into my REDCap project. There we go. Always a little bit slow when I'm screen sharing. So that way I know I have that validated instrument in there, it is in there correctly, and I do not have to go through the hassle of setting it up myself. I've got it exactly the same way anyone else using REDCap has access to with I know I have copyright permissions and I know it's been checked. So a great way to use standardized forms. So what does this look like for data entry purposes? I have all this set up as a survey, so we can go through. You can see a bit of branching logic here. I'm going to have to provide values on all of this. I provide consent. Provide my names in the required fields. You can see how it's piped this information to display elsewhere. If I provide this outside of the range, not the field I had specified. Let's go with that for now. Email address, this is also validated. And then here we're going to see that eConsent process where it's showing me an inline image of the PDF with all that information. It can be downloaded for the participant's record. They have to electronically sign and submit. And if I go to the file repository in REDCap, it stored the compact PDF there for me. And then it takes me to the next question, to the next form I had. And this is the one that I had validated. So it's going to give me an error message for being outside of the range. Letting me know I need to go back and double check that. Basic calculation, drop down, radio buttons, check boxes, and this has a none of the above feature on it. So if I try to click I don't know, it'll automatically clear my other options. My slider, videos. So data entry is really very simple and allows for a lot of different data to be stored in. And when I go into REDCap, then I can see my records. Everything's been filled out. And I can go in and I can see all the data that was entered. I also have here the history. So I can see when this was filled out, who filled it out, and what their answer choice was. And that will, and if I go through and change that, it will show every change every single time. I can also use the field comment log. So if there's a potential issue with this data or I want to make a comment on it, I can log it in here. It's visible in the data entry form for anyone who looks at it. and I can come to the field comment log and see all the comments that have been made. There's another version of this that even opens official queries that have to go through a full resolution process. To get this out, if I want to get the PHQ-9 then out to people on a regular basis, I can also set up automated invitations after I assign it. So this project's longitudinal, meaning that I want to define my events with different visits, and then say what forms I want to use on what events. So if I add my PHQ to my events and go back to the online designer, I can set up automated invitations to go out after the consent's complete, and then send 7 days after that event's been triggered. I can put in reminders, send every day, up to 3 times, and activate it. What didn't I select? No. There we go. And I can do that for all of my different events. If I can stop clicking on other buttons. And I can base them all off the same thing or different things. So that's an example of getting data into REDCap. And I showed you a few of the different checks that are going on there to make sure that the data is good. I validated my fields. I put soft validations on them. I use some special features called action tags, which you can see an entire list of many places in REDCap, but here's an example. Using things like character limits, default values, hiding fields to ensure the best data quality in each individual field. Some other things that you can do to ensure high quality data in REDCap are to use data quality rules. REDCap sets basic ones here for you. So you can search for blank values or in required fields only, look for validation errors, outliers, update all your calculated fields. You can also add your own. So for this project, I only want people who are over 18. So I set up a rule that age field has to be, if it is less than 18, execute in real time. So as I'm doing the data entry, throw up a pop-up and let me know that this is a violation of the rules I've set up in the project. And I can set up as many of these as I want to help me constantly monitor my data set and make sure that the information I'm putting in there is as clean as possible. You can also set up missing data codes. So a consistent problem with data sets is people just leaving things blank if something's uncertain or if there is no data. This missing data codes are a series of codes that you specify in one place where each value means a different type of missing data, so that you know exactly why there is no real data in that field. And you can verify it by however you want to for the project with whatever codes you want, but the codes will be the same throughout project, so you don't have to worry about forgetting what you used in one place and using a different set of codes someplace else. Honestly, even if the codes you're using are not fabulous, as long as you're consistent with them, it'll be so much easier to work with them on the back end, or for your analyst, or for an analyst to work with them. The number one rule of creating a good database is to just be consistent in how you're handling issues in it throughout there. We also talked about codebooks in terms of reproducible data. And REDCap automatically creates a codebook for you, a human readable version of it. So for every item, I'm going to get the variable name, the field label that we saw with data entry, the field type. If I have any specific extra items on it, so these fields are read only. All the coding for my multiple choice questions are available. It marks things that are required, things that have been flagged as identifiers. Here I've hidden the button so that they actually have to enter in the date. They can't just hit today. For text fields that have been validated a certain way, you can see how. Pull out calculations. So everything you would need to recreate this database from scratch is written in this code book that is automatically created for you and can be printed out as a PDF. REDCap will do that for you. You can also create a snapshot of your database. So this is the data dictionary itself created. I took a snapshot of it right then. And REDCap is going to store that for me in the project revision history. And once I move this to production, every time I make a change to the data dictionary, REDCap will store the previous version. So I have full version control of every change made to my project. When it comes time to get your data out of REDCap, your first decision is if you're going to want to do all your data or if you're just going to want to grab a subset. If you just want to grab a subset, you'll create a report, choose who has access, what fields you want to include. So let's grab some names, consent, and their feelings about the cat. If I need to filter some of this out, I can. So I only want this where age is, come on. There we go. Greater than or equal to 20. I could select by which event I wanted. But all this is doing is really just giving me a subset of my data, and REDCap is an EAV database, so you're always going to get this returned as a flat data set. It runs some very basic statistics for you, but honestly, REDCap isn't what you use if you want to get great, if you want to play with your data and see what the stats are saying. That's when you move to another program. So I would choose to export my data. So here I can choose if I want it as a CSV with the raw data, the variable names, the coded values of my multiple choice questions, or the labels. I can also export for any of the major stats programs, and it will give me a data set, and it will give me a series of files to run to format and upload that data set directly into the program so that none of that has to be done by hand. You also have the identification options for the security of your data. So I can choose to remove all tag identifier fields. I can hash the record ID field. In REDCap, we always recommend your record ID field not be an identifier. Identifiers they're terrible record IDs. You want it to be you want your record ID to be a unique random value. Making your record ID an identifier means that every single person who accesses your project is going to be seeing that identifier, whether they should or not. Also, if you look in the URL, you can see some information is being stored here, like PID is my project ID, my report ID. If I were in a record, the record ID is also being used as part of the URL. That means if I'm on a non-secure system, if I'm on any system really, I now have all my record IDs of someone's MRN being saved in my browser history. And that's just not something you want to deal with, especially with the way browsers interconnect. And you might be looking at it on a secured computer right now, but if that browser login is used someplace else on a non-secured machine, it's going to pull up the same thing. It can also create a really awkward issue if you're ever screen sharing with someone. You can choose to remove unvalidated text fields in the notes essay boxes, because any unvalidated text field has the option of having PHI in it. You can remove your date and date time fields. A constant thing to remember is any date below the year level that relates to a patient is considered an identifier for that patient. And you can also date shift so that you can do your date differences, but it doesn't tie back as easily to a calendar. If comma separated variables aren't your default, this one comes into play the most internationally. You can choose what is for your export. And you can also choose what your decimal format is going to be if you're not in the comma for thousands, period for decimals. That is so common in the US. So just doing a quick export so you can see. REDCap really just looks like a very basic flat data set, very computer readable, easy to use. You're not going to get any color coding. You're going to have flags, one thing in every column. Really a very straightforward CSV file. You can also export REDCap directly data via API. So, and I'll let the next presentation deal with that one. Two other features I want to demonstrate here in the last couple seconds. One is the logging feature. So we talked about reproducibility. You want to know every single thing that has ever been done in this project. It is logged. I know when, who, what, and then I can see the very specific actions. So every piece of data that I entered. If I completely delete a record, that the original data entry is still there. I can still go back and find it. Everything I do in this project is being logged so that I can do a full audit of the actions. This is even down to the page view level. I can go through and see who has accessed what page in this project at what time. And then the last thing I want to show you are project dashboards. And this is only going to be available to you if your REDCap is version 11 or higher. But this is REDCap moving into showing a little bit more in the way of statistics. So we've got the ability to pull bar charts, pie charts, donut charts, stats tables, using a series of smart variables. They've got a wizard here to help walk you through it. Well, you can see the smart variables. Smart variables in REDCap are things that change as you're going through. So the username will always display the current user's username. And if I scroll down here, these aggregate sums will constantly update with my data. So my charts, my tables. And the nice thing about these dashboards are that you can export them as a PDF to show off very easily. And then I can also make them public. So this will depend a little bit on your REDCap. Not everybody's allowing it. And you have to have a certain amount of minimum data before you can do it. But you can create this custom link that is unsearchable on Google, but that you can pass off kind of like a link to a Google Sheet that people can use to come and see this very basic report that you've put together on your REDCap project. So you can show a quick summary of the data without having done the detailed analysis, but so that you can do a quick update, keep people in the loop as to what's going on without doing full detailed reports. So that was me presenting a lot of information really quickly.
And there are a few questions in the chat, Amanda, and they also asked if you could drop a few of your links in the chat. That would be really cool.
Yeah.
I also wanted to mention for folks who haven't seen it, our poster session is tomorrow. But if you want to, I dropped the link in the chat to that. A lot of the posters are already up, so you can explore that in spatial chat if you'd like. And next, I'm going to turn it over to Will Beasley, who's going to be presenting on, now that you've got all your fabulous data in REDCap, how do you reproducibly get this out and pipe it actually into your statistical analysis in R?
Hi, thank you. First, I wanted to make sure everyone knew Amanda was kind of underselling her videos. She's won a bunch of awards at the national conference, including for her videos last year.
Thanks.
All right, so REDCap API. It facilitates repetitive tasks. So if you only have a data set that you know you're only going to need to download and analyze once, go ahead and do how Amanda showed to download that CSV and run with that. But at least in my life, that never happens. That single shot just doesn't exist. I mean, the patient data set hopefully is updated every day with relevant, fresh information. or you're running on a different computer a few months later, or, and this is the core of reproducibility, you want someone else to be able to unambiguously and effortlessly produce the same result as you. So instead of telling your colleagues or students, go first to REDCap, then go to project 55, then click data exports, then click export data, then download these files, then move these files to this subdirectory and finally convert them to format. Say it with a few lines of code. Say it with something like this. Your life will be easier, so will theirs. And for people running the code on their machines, especially if they're on the same campus, API is so integrated and it's responsive. They may not even realize they're connecting to the outside world. They may think it's on the internal package they've already downloaded. For beginners, most of the work is just managing the passwords, the credentials, which is just part of the reality of working with PHI. So I am following a vignette here. In the link, it looks like this. And you can copy the code like this and plug it into RStudio. Any R thing. Okay, so first, let's make sure that REDCapR, the package, is installed. If it is, if you run this line of code, you should get nothing. If you get an error saying there's no package, install it. Most people here, I assume, know that if you want to install it, this code will install it from CRAN, and this code will install it from GitHub. I'll give you a few seconds to use this chat, which is in the window, to pull it up. Okay, before we get to R, handle some kind of REDCap tasks. Talk with your admin to make sure you have access to the server to start with. 2, that you have access to the specific project. And 3, that you have the token. And this may be the first time that you've asked for a token. Each institution has a different formal process for getting approval to the API. Your REDCap administrator can help out with that. But we don't have to worry about these 3 for the demo today. We'll be using a fake data set hosted on an OU server with this token. If you're talking to your REDCap admin, this website, so the link that I put in, or where's it here? It has a little note for your admin to kind of nudge them how to do it a little more quickly. All right, as Amanda showed, before you start hitting REDCap API, go to the codebook. So in the main page for a project home design codebook, and this will have all the variables. If you spend a few minutes doing that, it won't be wasted. In fact, I think most of us recommend that you spend more than a few minutes looking at this, and ideally you spend like 30 minutes with the investigator to learn the context of the research, the collection process, any idiosyncrasies of the data set. And as you're talking out, I recommend explaining to him or her how you're planning to do it and how you're planning to groom the data to make sure it's consistent with their understanding. They're not going to understand the models probably that you're going to do, but they'll probably understand how you're planning to convert gender to what you want, or convert some lab to analyze. And ideally that process starts as early in the investigation's life as possible. Okay, let's go back to the R part of it. And we need to retrieve the token. If you're using a real data set with PHI, it should never be accessed from an R file with a line something like this. That it's not secure enough. The token is, you pass it to the URL, to the URL of the server, and it instantly knows pretty much your password, who you are, and which specific project. So you don't want to make that vulnerable at all. There's two ways that we recommend protecting the tokens, and we're going to do the easier one for today. I recommend, one of recommendations, have a CSV, and REDCapR kind of has this format for CSV with these 5 columns, and store all your tokens in one file and save that file in a very secure location, not in the GitHub repo ideally, and ideally somewhere local that's encrypted. And once you store that, and you store tokens like this, you can retrieve it. And so in this case, we're going to use that kind of fake token file built into the data set. I'm sorry, built into the package. So, this path is going to be different than you, but for your computer, but it's essentially just a string. And you pass that string and the specific project you want to this function. And we still haven't talked to REDCap. This is just retrieving your protected information, and it returns this object with these 5 elements. And the 2 important ones are the URL and the token. In this 53, you're specifying that because in this token file, there's 3 different projects, and it's being really specific. I want this guy. If you need to create a credential file, either copy this and kind of replace it, or there's a little function here that will start you out. Okay, so that's what we're going to do today because it's the most portable and easiest for everyone to do. However, there's a method that I like a lot better, and it's basically storing this tokens in another database that's accessible only with LDAP. And so it's easier to maintain, but still your institution manages the password. That's a pretty long process, and it's described in depth in this vignette, how to create this database. All right, let's start retrieving data. The basics are pretty simple. So we retrieve that credential file, and just as a reminder, nothing special to it. It's got the URL and the token. And we pass those 2 pieces of information to the REDCapR function called REDCapR read, and it spits out these guys. It tells you what data sets what columns were retrieved with what format. And at this point, you can get moving. You have, can I scroll here? You have this data set with 25 columns, and you can do all the basics like summarizing and modeling, and all the other exciting things that are in the next 2 days of R Medicine. So it's kind of tempting just to stop here and say you've accessed the data. Actually, let me pause here for a minute. Give me a sign if you're following along and want some more time.
You can click on the reactions button and use a thumbs up.
Okay. Give me a crying reaction if you want me to go through that again, briefly. A slow down. All right, I gotta slow down. Okay. So essentially, there are 2 things you need to execute. You know what? I'll mimic what you guys are doing. So the first thing we need to do is retrieve it from the token file. So I'm going to copy this. And if you have REDCapR installed, you know what? Let me back up. Run that code in the chat to install R. And now that R is installed, or I'm sorry, not R, REDCapR. Now that REDCapR is installed, you'll have this file built in. So we're going to get this file and then pass that string, pass that path to this function. And I just pasted that in the chat. And now that you have this file retrieved with the URL and token, pass that information to REDCap read. And let's take a peek at the data. So I'm holding click down, and you know what, I'll do it where you can see. So here we are. You have the full data set transferred from REDCap from the server to your local machine. Give me a thumbs up if you're ready, or a slow down if you'd like me to slow down. Oh, I forgot the, here's the third snippet to pass the credentials and get it from REDCap.
Could you explain a little more in depth about what those two functions are doing? So path credential, it looks like it pulls a list, and then we're
Yes,
pulling from that with REDCap read.
Sure. So path credential, nothing special here. It's just a string that happens to point to the location of the file. And that file just comes with that REDCapR package. So you'll need not today, but when you start connecting to your own REDCap, you'll need to modify this file so it contains your tokens, not these tokens to the demo site. So path credential is nothing but a path, and you pass it along with whatever ID of the project you want to the retrieve.
Typically,
and all. Go ahead.
local administrator will give you an API token, which is this long hash string, and you just have to store it somewhere secure. And like, yeah, exactly. And then once you have that and you have it in a stored location, you just have to tell REDCap, okay, this is what my token is. And once it's in there, you're good to go. You can read your data, multiple times a day if you want.
Yeah, we have some automated tasks that pull from REDCap every 5 minutes and basically populate this dashboard for nurses to monitor. Okay, so really the hard part, I mean, the point of this was just to get this 32-bit or 32 character hash value. And then we pass that value here along with the URL to here. So if you really wanted to, like if PHI was not involved, this code would be a lot simpler. You just say, here's the token, and you might hard code the URL too. And then all this would go away. That's basically all it is. But because we're taking a few extra steps to protect the token, that's kind of extra jump.
Great, that makes sense, thank you.
And so, yes, it could be saved in an Excel file. I strongly suggest CSVs instead of Excel. Okay, so we have the data set again, looks like that. And it's kind of tempting just to stop there. You've got everything now, go analyze. However, I strongly suggest you do a few things to be more stingy. So be stingy about what columns and what rows you pull from the database to your local machine. And the first time, I think it makes sense just to grab everything. But as you start refining your analysis, I'd start trimming down, and for a few reasons. If you're filtering, the server is almost always more efficient than R or Python. And if you have 1,000 records and you only need 500, the CSV or JSON that REDCap's PHP code assembles is a lot quicker. And of course, less is going across your network. And R doesn't have a big data set, as big of a data set to manage. So that's a little more responsive. 5 might be the most compelling to me. We've had REDCap projects with 2,500 variables. We're not analyzing 2,500. We know that stats only cares about maybe 200 of the variables. There's no reason to overload your brain with an extra 2,300 variables. Keep it simple for your brain. And another one that's compelling is a lot of things are collected by REDCap to help project management and recruitment and tracking the participants. You don't need their phone numbers. You don't need their socials. Just keep them on the server. Don't expose that. So how to be stingy? The most direct way is limit the rows. And here you can say this isn't row 1 and row 4. It's participant 1 and participant 4. And you can pass put that in a vector and pass it. And now instead of 5 variables, we have instead of 5 rows, now we just have 2 participants. Now, realistically, you don't know those the IDs of what you want. More realistic scenario is you want to limit it based on some variable. And here we can pass a filtering logic to it. And REDCap's filtering syntax is pretty SQL-like, but read the documentation, there are some differences. The main one that gets people is you have to put your variables in square brackets. Database, you only have to do it if it's got a space or some kind of misbehaving character. You always have to escape your variable names. And then also sometimes there's some differences between REDCap stores everything as a string, like most EMRs do in their ops table, everything is a string. And so pay attention to that sometimes. But you certainly can do some inequalities. So let's do this. So same data set, same project we're hitting, but now we're doing these filtering and we get a different 2 records, people born in the past 18 years. Another way to be stingy is specify the column names. And this is pretty straightforward. Just pass the column names in a vector and pass them to fields. So now instead of 25 columns, we have these 3. You know what? I wasn't going to do this. I'm going to do it. Another realistic way. So if you only have like 10 variables that you're doing, that makes sense. Sometimes though, you'll say, I want the demographics and the health instrument, and you don't want to specify all 10 of them. And even if you don't mind doing it, it may change in the future. And you may want to include all the variables in those 2 instruments. Basically, you can, instead of specifying the exact fields, you can specify the exact forms. Forms and instruments are synonyms. So you can do records, fields, forms, or logic. Okay, so that's part 4. You know, we started collecting, we started retrieving everything kind of as we're learning it. We start getting, no, unfortunately, there are no regexes in filtering. That'd be nice though. So we started by getting the big, all the data, then trimming it down to what we need. And now I encourage you to do an extra step on top of that, especially if you're worried about, especially if you're using it for automation. So what's happening, you know, REDCap stores everything as a string. It assembles it, the PHP code assembles it as a JSON or CSV, ships it across the network. REDCapR gets it and then passes it to Reader. You know, Reader, of course, is the package in tidyverse that takes strings and creates data sets. Takes big strings, creates data sets. Reader will make, unless you tell it what to do, Reader will make its best guess about what variable, about what data type each variable should be. That's a good way just to start. But if you're doing automation, I don't like just to leave it guessing. And, you know, even if it's guessing right at the time, you know, someone could enter some bad data later on. And instead of now everything being a number, there's some characters in there. And now our REDCapR reader, that's all going to behave differently. So be really structured. Now, the real way to do it is how Amanda showed you to use validation and don't let any, in this case, characters go into numeric fields. But, you know, realistically, that's just going to happen sometimes. We can't catch it all. So another layer of defense to be robust with your automation, or even if it's not automation, with your code, is to specify the structure you want. So in this case, we're going to say, give us 2 fields, record ID and race. And for record ID, integer, and for these other guys, give me Boolean. Actually, let me go back one more time. So here, before we specified a structure, you know, here are the values, and Reader made the very reasonable assumption that these are numbers, and it wants, you know, it's kind of stat oriented, not database oriented, maybe. And so it's going to give it the more permissive floating point data. That's double precision floating point. And that may work for age. You don't want floating points for IDs. So let's lock it down and say, I want this ID to be an integer and the rest to be Booleans. And so we're going to do this. You know, that's just a vector of names. This is this call types object from Reader. It looks something like that. And now we're going to pass those 2 things to REDCapR. And notice this is no longer a double precision floating point. It's a nice tight integer, and these are nice tight Booleans. Every now and then it may make sense to not have Reader do it. You want control of the data type. In that case, I suggest doing something like this. Tell Reader, just by default, make everything a character. Oops. So if you do something like that, I'm going to keep it on the screen here just to make the comparison easier. Notice it doesn't automatically convert the 0s and 1s. So it's stored as a 0 string and a 1 string in REDCapR. In REDCap. Reader, REDCapR converts it to here. It's my preference, but sometimes you just want the straight up string. And one of the times that comes up frequently is with dates. If you forget to put a date validation on, you know, as Peter talked about with Excel, you're going to get a bunch of different formats, and you're going to have to use different algorithms if they went day, month, year, some rows, and month, day, year. In that case, you'll want to pull it in as a string, or maybe everything is a string, and parse it yourselves. Let me stop, look at the questions. Yeah, Raymond, I wasn't going to get into the longitudinal, but but yeah, but I will. If you have a longitudinal design, and let's say, so if you can see my screen now, there's one, is that big enough? Yeah. One row record per person. A longitudinal design, as Raymond apparently knows, has multiple rows per person, one row per event. And what you get is kind of this sparse matrix, especially if not every variable is collected for every person, every event. And a few ways you can do that. Someone mentioned tidy REDCap in the chat. That's one approach. Another approach I like is to call REDCapR multiple times, once for each instrument. And so therefore it's kind of already normalized in different data frames. And then I have more control about how I piece it together. And so, yes, it will null out, it's coming from REDCapR, not as nulls. It's coming from it's coming from REDCap as zero length characters. And then depending on which reader options you have, and if you have the default, those zero length characters are converted to NAs and R. So it'll kind of look like this block matrix that's kind of sparse. Caitlin asks, is there a way to parse the string with white? Yes, okay, so I'll dig into this a sec. So here is the codebook, and notice the way race is defined here. Let's go here. It's multiple, so a mixed person would have multiple selections, and the designer calls it the race variable. REDCap will add 3 underscores and then the ID. And so then it comes out like this, but as Caitlin points out,
so
race,
so for something like ethnicity, I guess, is there a way to get the the data dictionary value, the string Hispanic Latino, not Hispanic Latino, instead of zeros and ones?
There is. Okay. So I'm looking at their
yeah, I when I wrote my example, I didn't realize that race was coded the way you had it coded. Sorry about that.
No. So if it's a label like that, by default, it's raw, and the other option is label, and that should produce, instead of 0, 1, 2, produce these guys. Cool. And then Kenny, I was going to have 10 minutes of your time. Is that right? Or do I need to wrap up? Is that what we decided last month? Cool. Okay. So we collected we transferred everything over in that part 4, part 5. We selected it down to only what we needed. Is that right? And then part 5 was we added structure. I think if you did that, you've had a great day. Go forth and analyze. And I would do that a few times. And once you're comfortable with parts 1 through 5, come back to this, part 6, and think about if any of these next steps make sense for you. Dig into REDCapR resources. We've looked a few times at the documentation. I love the package down package, which creates this, great website with no extra effort once you write the documentation. These vignettes exist for a bunch of different scenarios. And I think my favorite one is this troubleshooting one. And the first third of this isn't even related to REDCapR or maybe even R. Yeah. And many people, not just me, have added to this kind of troubleshooting guide. And the first third involved just, can you connect, forgetting R, forgetting REDCapR. can you connect? And over some years and lots of feedback and people using it, this can identify like where it's breaking in the pipeline pretty quickly. And if you find something new or something, please email me or send a pull request. Another thing is what we've described, you know, this code, something like this, I think makes sense for a small project and you're about to model it. But we've had, you know, this 5-year longitudinal project with a few thousand people. And I think we've had 10 statisticians over the lifetime, like 3 or 4 at any one time. You can imagine there's a lot of R code analyzing it from different angles. And almost all of them need race structured well and record structured well. So instead of, you know, and with thousands of variables, instead of copying and pasting this over and over and over again, think about separating what's the analysis part, put that in an R file and as many R files as you need, but then pull out that structuring code into its own file and do that once really well and have all those other analysis files call it. In the software patterns world, that's called a gateway. This is a one-way gateway that we kind of call an arch, and we've described it a few places. You know, don't start out with this. Do this a few times, but if you find yourself having to copy and paste that kind of access and structuring code a bunch of times, do yourself a favor, pull it out in a single file. That's called repeatedly. All right, and also now we have this data set. You know, the whole R world is open to you. Certainly look at any book for reproducible. I'm really excited about Quarto, which is, I think, more or less a successor to R Markdown. And that's coming up tomorrow in R Medicine. Last year's presentations had a lot of good stuff. And of course, any book by the developers of Knitr and R Markdown are worth reading.
You can put it in the toaster oven. It works well in there. I would just use a foil.
Kimmy,
and
can you
could,
mute yourself?
like put the spray on the foil so it
Can I
doesn't
mute
stick.
Kimmy? I'll mute Kimmy. There you go. All right, batching. I'm really conservative here. When you read from REDCap using this function, a lot of times, you know, there'll be a few thousand records. Under the covers, it's calling REDCap repeatedly, just grabbing 100 patients at a time. And that's just, in my experience, that's just the most robust way of doing it. So there's no timeouts. If it's working for you, you can increase that batch size. And I try to aim for, you know, 5 seconds per batch. And then REDCap behind the covers is taking all those little batches, sub data sets, stacking them together, converting it. So it won't affect your results at all. It may just affect performance, messing with the batch size. So far, everything we've talked about is consuming REDCap. You know, that's mostly what we do as statisticians, but there are a lot of times where you want to write to the server. Writing to the server and reading, those are only just 2 of at least 20 API functions. Writing has its kind of own things to do, and it's a big part of Kenny's talk in a second. After a 5-minute break. And let's see. If you are doing R and you're thinking about hidden REDCap, you may be tempted just to use rcurl or HTTR, the tidyverse package. I suggest not. And, you know, I'm biased because I'm one of the main developers of REDCapR, but using one of those, you could probably do it in 5 or 6 lines. REDCapR uses a lot more. It's got a lot more to handle different situations, a lot more validation. There's tests for everything. And if REDCap does add something, add a new feature or changes something, you don't have to change anything, right? You just have to hit update packages. And that's a huge advantage. I'm going to pat ourselves on the back as the R world. That's a huge advantage we have in R over something like SAS with macros. I did a little search just a second ago. In R, in my group's repository of code, there's at least 124 times that we read from REDCap, and that includes arches, which has a lot more, and then write another 60 times. I don't want to have to go and figure out which versions are going to break and go to all these, update them, change them, and make sure nothing else broke downstream. Stick with the package, and if you see something that's not working, please tell one of us in the GitHub issue or something. And then finally, Amanda showed you the flat file, and it absolutely can be represented as a two-dimensional, flat file. But I didn't want it to be undersold how much hierarchy it can do. So it can't do a hierarchy in the way that a traditional relational database can, where you can have many, many tables and arbitrary foreign keys. It can't do that, but REDCap hits the sweet spot of patient research really well. So it's really common for us to create, like if an investigator wants kind of a little batch of his data coming from the EMR, one record per patient. Each patient can have multiple, let's say, events, hospitalizations, and each hospitalization can have multiple blood pressures, multiple labs. So it does have some layer, it does have some capability for hierarchy that fits really well for most patient-centered research, in my experience. Okay, any questions for now? Oh, and Judy mentioned, great, yeah, that looks cool. She's got something that hooks up Shiny and REDCap tomorrow, no, in 2 days, 2 afternoons. Thank you. All right, thank you, Peter.
Okay. And I think at this point, we're all going to take about a 5-minute break, just stretch, get a snack, go to the bathroom, whatever, and reconvene at 14 minutes after the hour. And then we'll step it up to multi-center studies using the Collaborator package, and Kenny's going to present that. We'll see you back at 1:14 or 14 minutes past the hour, whatever time zone you may be in. Okay, I think everyone's had a break and it's time to scale up. We started low level with Excel, moved on to REDCap, how to get data out of REDCap. Now Kenny's going to talk about taking on a large multi-center study and bringing all that data together and how to manage REDCap across centers.
Fantastic. Thanks very much, everyone. So my name is Kenneth. I'm a clinical research fellow based in Edinburgh. And just to kind of talk about some of the experience that I've had in trying to not just use REDCap at one center, but trying to work efficiently when you start trying to get more places involved and more sites. But I imagine everyone's kind of aware that there's been a lot of sort of legitimate move away from kind of just single center stuff, because there's recognition there's potentially more value and studies get done quicker if it's done multi-center and that kind of thing. So this can be a really sort of useful application of REDCap. It's got some really good features built in to kind of help deal with that. Just for some context, this is all aspirational stuff and not what you're going to be probably doing right off the bat. But REDCap can be used for really massive projects. So just some ones that I've personally had sort of experience in. There's what projects that have been done with thousands of patients across 150 centers, 1,800 collaborators, right up to hundreds of thousands of patients, 10,000, 15,000 people all using REDCap to collect data from sites, not just in UK and America, but across the world on a global basis. So it's a fantastic resource to kind of try and bring lots of data from other places together in a way that's all contributing, answering the same question in the same way and that kind of stuff. So it's a really fantastic platform for standardizing like that. But you can probably imagine with tens of thousands of collaborators, with hundreds of thousands of patients, very, very easy to get overwhelmed with how you're managing all of this in the background, because all of those people need accounts. All that data needs to be sort of checked and cleaned and that kind of thing, which is a huge thing for one central team to try and do. So some of the potential issues with multi-center research that are sort of worth considering is how we kind of try and make sure that that data remains protected among different teams, and that only the people that should be accessing that data from a particular site can access that data. So how that's managed within REDCap is within what's called data access groups, or DAGs, which are basically ways to link different users together and different patients together under one sort of umbrella, which is sort of just a subsection of the data set, which those users they're the only ones who can access that, and they upload patients within that DAG data access group. So they all sort of stay nice and together. And that makes sure, from a confidentiality point of view, there's not going to be inappropriate data access from other teams for whatever reason. As I sort of mentioned, the issue of this comes in when you've got lots of people who need access to their very specific team, to their DAG. How do we kind of manage that? And REDCap, as I said, fantastic platform. It is the best platform for this purpose. It does have limitations that do become more apparent as the studies sort of get bigger. And as I've sort of indicated before, the kind of administration around these projects, particularly managing missing data, monitoring data going in, kind of thing, can be really difficult to do live, which is really the time where you can do something about potential problems. So without kind of ways to manage this, make this a bit more efficient, that can be really, really difficult to have done in real time and can affect the quality of projects. Data completeness, projects live and die on that. So if you've not got much data or you're missing some key outcomes, then you could really hamper what you could achieve with the data. So that's kind of where this package that I've developed has come in. So it's called CollaboratoR, and is basically a kind of host of functions that myself and a few other people who are involved in these sort of large scale projects have kind of developed over the years to try and just make these things a bit more efficient and work better at scale, meaning that it's just as much effort to do something for 1,000 users, for 100 users as it is for 1,000 users, or similarly, across 100 patients or 10,000 patients, and can be used in theory for whatever REDCap projects you do. So it doesn't necessarily need to be done for multi-center research. It works for single center stuff just as well. And as Will was kind of talking about earlier, REDCap has this fantastic API that you can push and pull data from into and push it back into. So it makes use of that to do a lot of this kind of stuff in the background. So when you're thinking about managing projects like these, particularly multi-center ones, there's kind of different aspects of the project that cause the most or burden for administrating them. And this is potentially things where you're doing repetitive things at scale are fantastic opportunities for kind of automation. So obviously designing REDCap projects, there's needs a lot of that human element to sort of do that properly. So can't really automate that. But making sure that you're getting users allocated to the project to the right team kind of thing, that's something that can definitely be automated. Data collection obviously needs to be done by people, but that aspects of monitoring the quality of data going in, the amount of missing data and so on, is easy to automate. And similarly, the kind of more data cleaning aspects can be automated as well. So this kind of different areas where these bits in blue are the bits where CollaboratoR has some functions to potentially help deal with these aspects and make things a bit easier. So I'm going to switch screen to a markdown document I've prepared earlier. Everyone should hopefully be able to see that. So I'll take through just a few sort of examples of how this can be used in practice, and a bit more about, I guess, how these different aspects of REDCap work. So if you're kind of using these sort of functions for yourself, a lot of it is based around sort of tidyverse, so you want that package installed, and you can find the CollaboratoR package on my GitHub at the moment. I still need to put it into CRAN and that kind of thing. That's on my to-do list. And throughout this sort of document, we'll be using a ready-made REDCap project, which is sort of, it's all made up data, but it's sort of based on an example of outcomes of patients after a surgical procedure. And similarly, for this, we're going to be assuming that all the data access groups, the DAGs, have been made, and all the users who need users have an overall REDCap account. So for those who haven't used REDCap before, users who are going to be doing the data collection or whatever role need an overall REDCap project, overall REDCap account, which gives them access to be able to log into REDCap, and then you need to give them specific access to that particular project. So there's kind of two steps that need done for people to be able to log in and properly access the data. Yes, I'm very, very happy to send sorry, I should have done that earlier. I'm very happy to share this document around for anyone who wants it afterwards. So one of the kind of most helpful kind of aspects are adding new users to REDCap. So let's say we've got maybe 50 users who want to add to various different hospitals that are involved in this project, and we want them to be able to enter data. These new users can be added to this project manually. So basically adding each user one by one. That can be very sort of time consuming, very error prone, particularly if you're doing it just one person. So if there's any ways we obviously can automate that, that's obviously incredibly helpful. So the kind of first way to do that is you create a user, just a single user manually on REDCap who has those user rights that you want, who has the rights to be able to create new records, to add new data and that kind of thing. So this is via this sort of side panel here, and you can click user rights and you get basically the ability to add new users to that particular REDCap project. So let's say we've made one called A Barker, who we want to be a data collector. and she can, edit new records, but we don't necessarily want her having access to the API because we don't want her pulling all the data, and potentially maybe we don't have permission for her to do that. And we don't want her further modifying her user rights, just again for data protection purposes and that kind of thing. So you'd want to first create this user, as in the person who has the rights that we want for all the other users that you want to be adding. And you can create a data frame of all the new users that you want to have her exact role. So all the data collectors in the project, just create a data frame of them. And you need a minimum amount of information to be able to add users to REDCap. So they need to have a username, need to have first name, last name, and an email address. And then if you want them to be allocated to a specific site, a particular data access group, that also needs to be provided there. So, these are various hospitals, D, E, H, wherever. And these are all randomly generated names and emails, so no one's being shared inappropriately. So you've created that template user, you've got all the other users that you want added to REDCap. And then we can start the kind of slightly second point, which is using the code. So you can use this function called user assign, and that basically works with that with the information you use to use the API in the first place. So the URL of the project, the API token that you've made before, and then the data frame of new users that you want to add. These are the new data collectors, and then this is the template person that is acting as, this is the person that we want everyone else to have the same rights as. So everyone should be data collectors. And then basically you'll get, these are all sort of pushed in one by one. And by the end of it, you should have, 33 new users added to the project and that kind of stuff. So it turns a project, a task that could take, maybe 15 minutes, half an hour if it's just 30, but potentially days if it's 10,000 users. Into a task that kind of just runs in the background automatically, and you can get all these people added to the project much more efficiently and much more accurately than a human trying to do that. And there is sort of like an online vignette that kind of goes into more detail of how you use it and different aspects of how you do that. But that's kind of just a sort of basic outline of how you can very easily add users automatically to a REDCap project without having to, handle a lot of that yourself. Another aspect of some of the things that you might want to do, within a single center project, but particularly with multi-center data. Data monitoring can be really, really difficult at scale, and particularly in the context of multiple teams collecting multiple data. You kind of want to make sure that that data is coming back as accurate, so you can then potentially contact those individual teams to update them if it's not, or if there's issues and that kind of thing. There's also the aspect of kind of social media and updating progress, and particularly when you've got lots of centers from lots of different places contributing data, you kind of want to keep them updated. You want to keep them engaged and enthused about how the project's going. So again, this can be a way of easily getting some summary data out to be able to share progress and things like that for social media, or even just internal emails and that kind of stuff. The kind of trouble is that REDCap tends to kind of the summary information that you automatically get from REDCap tends to be at the overall level. So it's difficult to get very accurate information of how each individual center DAG is doing. And it could be potentially quite challenging and time consuming if you, weren't using R or that kind of thing. So basically a couple of functions we put together. The first one is about summarizing the multi-center data that's already present. That's REDCap sum, just uses the simple information. So basically the information needed to connect to the API, does all the complicated stuff in the background. So where you might use an overall summary of the number of users, hospitals, patients that have been uploaded. This is an example of one that's done for a previous project that basically there was every week or so, there was a kind of update on the number of countries involved, number of hospitals, number of patients, and that kind of thing, to show people the progress and sort of enthuse people. And basically, once you run this function, you get that overall summary just automatically from it. And you can kind of access that using $sum overall. And you can basically get this exact information. So this was the function used to make this, and we basically just ran it every week. It very easily got that information out. But say you wanted a more individual summary, so a more center level summary. It's difficult if you're just getting overall information to know which sites are needing support or are having issues or are doing really well. So another example from a project here of a multi-center study is basically they wanted to have each site and the number of patients uploaded and do a leaderboard showing how many patients have been recorded, and just to kind of enthuse people, and again just give particular centers recognition for how well they've been doing. And you can get that at the same time, same time as you're running the original REDCap sum function. You can just do DAG all, and you basically get that same information out. So the number of records uploaded, the number of records that are complete, portion of ones that are complete, number of users at each site, and that kind of thing. So that can be essentially used to make this sort of diagram or similar ones, and can be used to potentially target centers that haven't uploaded any data. You can very, very easily tell that and potentially give them a bit more support, contact them, make sure the project's running well. So simple thing you can do, but it actually can be very valuable when you're working at sort of larger scales. And again, there's a vignette on that, and I'll certainly share this document around if anyone wants to learn more about that. As I've kind of spoken about before, there's aspects of missing data, which, as I said, obviously is really, really important, to minimize within projects. Otherwise, particularly if you're doing regression or that kind of thing with, pairwise exclusion, it means that you could potentially lose a lot of your data if you're missing variables for some very, missing data for some very key variables. The difficulty with REDCap is particularly when you kind of run into when you're using branching logic within your project. So you can obviously have questions that appear or don't appear depending on what data has already been entered. And REDCap can't tell whether or not that data, it doesn't really, it provides some summaries of how much data is missing for particular variables, but doesn't actually really account for whether it should be missing or not. So for an example, we've got a variable here, which is the severity of respiratory complications after surgery. And if you look here, there's 710 patients that this has been filled out for, but there's over 11,000 patients that have this missing. And the kind of difficulty here is that this variable is a branching variable. So it's only appearing if they say, yes, this person has had a respiratory complication after surgery. So it means that you don't really know if you should be chasing up those, should we be chasing up these 11,000 patients for their missing data? Actually, no, it's only a fraction of those that actually haven't filled in this information yet. And so you could be badgering people for, essentially something that is completely not their fault and more an issue of how REDCap's recording stuff. So issue is, how do we kind of tell the difference? Because REDCap can't necessarily do that by itself. And this is where we've developed this function called report miss, which again, very, very simple to use, a bit more complicated in the background. But essentially what it provides is, firstly, a summary of all the missing data at the overall data access group level, so each hospital level. And this can be used to potentially identify centers that are kind of struggling with missing data. So you can get this information out, and you can get the number of patients that have been uploaded by each center, and the number of patients that have more missing data than a certain threshold. So if they have more than 5% missing data, in this context, they get highlighted. And what this does is it accounts for that branching logic, which REDCap doesn't do in the first place. But basically this works out what variables have missing data because it is genuinely missing and needs to be filled in, or it's missing because the branching logic that would make it appear hasn't been fulfilled, and therefore the collaborators don't know it exists, and the data collectors don't know it exists, and so they shouldn't really be penalized for not collecting that data. And basically this works out that for us, and basically just get an understanding of who might be struggling with this kind of stuff. What it does as well is that's helpful for the study organizers, the steering groups, but that's not always as helpful for the people who are actually collecting data, because that's kind of vague information that somewhere you've got missing data. So what this does as well is it gives patient level missing data. That's obviously, you need to be extremely careful, obviously, when you're sharing any sort of patient level missing data stuff. And so we've kind of made sure that this function builds in that all the data is anonymized apart from the hospital and the record number, and all the other information is anonymized and doesn't give information on the actual details being entered. So it can be helpful for data collectors to kind of more pinpoint exactly where their data is missing, and hopefully sort of improve data completeness. So basically this is just a way of just formatting it for this purpose, but basically it's the output from the function, and then you can do record, and then basically you get this out. So it's giving the record ID, the hospital site, and this is for each individual patient as a row, which hospital they belong to, how many missing data points they have, how many fields there are in total, how much missing data is missing for that particular patient, and it also gives appends all the data, the whole data set to that patient there. It's all been anonymized, so if it sort of uses the code, so if it's just a full stop, that means that the data is there, it's present, don't have to worry about it. If there's an M, it means it is appearing to the collaborator, so it's not, so it should be filled in by the collaborator, but it's not been, so it's missing. And then you have these at the end, which are basically, these are all branching logic questions that haven't been fulfilled, and therefore they're not applicable for this patient, they're not relevant to the missing data count, and so aren't counted by the function in this sort of missing data stuff here. So that's just a way to, again, give a bit more support to people who are doing it, be able to get a sort of very easy readout of the overall amount of missing data present in your data set, and target efforts for improving that. And there is another sort of vignette. There's ways to sort of customize this and do other stuff with it and that kind of thing. And as I say, very happy to kind of share this round. So that was a bit of a whirlwind through. I hope it didn't go too quickly. Very happy for any questions on any of this stuff. Again, this might be more aspirational for people who are kind of just starting out at the moment, but multi-center studies are fantastic ways to very efficiently do studies, get lots of people involved, get data quickly, and get outcomes for patients quickly. So it's worth sort of having to think about how you can, if you do want to do it, how you can do that efficiently.
So for folks watching along, this may be a little bit of a stretch to imagine having hundreds of thousands of patients, but it is doable as you scale up. Any questions overall, or pick just questions and feedback about the workshop? And was it what you expected? Are there other topics that would have been nice for us to cover, or would it be helpful to have other resources and drop a few links in the chat? Okay. Thanks, Mary. Okay. Super. Great. Well, it sounds like it's been very helpful. I would encourage all of you, our very first ever poster session is tomorrow. I dropped a link in the chat. The posters are actually up if you want to explore and experience spatial chat during the main meeting on Thursday and Friday. Spatial chat is where we'll have our breaks, and it is a virtual setting, but it actually is remarkably good at being able to sort of mimic the break time at conferences. So give it a try. And Caitlin asked if, can you use your talk? Yes, absolutely. And feel free to download the slides from the Google folder. Caitlin, if you'd like me to email you the PowerPoint, let me know. Be happy to do that. And anybody who's had trouble accessing the resources with the Google Drive, let me know. I'm sure we can find a way to work around it. Okay. Well, thank you, everyone. If you have no more questions, I think we've covered everything for today. Parts of it were whirlwind, and we covered a lot of ground and a lot of range. We'll drop a few more links. Amanda, I don't know if you could drop the links to your videos at Colorado, since they are award-winning and fantastic.
Of course, just a second.
Sure. Awesome.
So here's a link to our, oops. There's a link to our info page that has everything on it. You can also find us at UC Denver REDCap on Vimeo or YouTube.
Okay, awesome.
And there's a website that's probably accessible to none of you. Unfortunately, it's accessible only to REDCap admins. But if you have a question and you're feeling isolated at your institution, talk to your REDCap admin. They can go to that site and then they can get more resources. It's called Community, the REDCap community site, if they don't know what the REDCap forums are, but that's another resource too.
Great. Okay. Well, and Kenny's our markdown. And yeah, Kenny, I think you have everyone's emails from the emails we circulated right before the session this morning. So if you could send that out, that would be awesome. I think everybody would like to see it.
Yeah, definitely.
Okay. And hopefully we will see all of you virtually in the next couple of days in the spatial chat and in the sessions at the main part of our medicine. And feel free to ask more questions, but this is all of our content. Thanks for coming. And we will end it here.